commercial and industrial synthesis of methanol and ethanol. So methanol, ethanol, these two are the good solvent for the industries as well as commercial purposes also. Let us see how methanol is prepared. So methanol is prepared in presence of steam giving by high heat. So first it will form product carbon monoxide and hydrogen. So under again catalyst, presence of catalyst zinc oxide and chromium oxide, so you will get 200 under pressure of 200 to 300 degrees centigrade. So in this temperatures 200 300 atmosphere, in this temperature what will happen, it will convert into methanol, and methanol is very highly poisonous and this is used in paint and varnishes. So see, this pressure is not a small, very high pressure, because our atmospheric pressure 1 atmospheric pressure and this is 200 300. So under this high pressures we are getting methanol. Similarly for ethanol, this is produced by the fermentation of carbohydrates. So carbohydrates we normally will take sugarcane juice. So sugarcane juice is first it is crystallized, so we take out crystals from the sugarcane and the liquid left behind is called molasses. This molasses still contains 30% of sugar, so still we can derive this 30% sugar from the molasses. So here we will do two type of process. One is your aerobic. So one is aerobic respiration, so if you give sufficient air it will convert into acetic acid. One is your anaerobic respiration. If you give you less amount or limited supply of air, so it will fermentate and convert into ethanol plus heat. So this is exothermic reaction. So again this sugar in molasses, we can get sugar from molasses, we can get sugar from the grapes also. Both contains the product called sucrose. The sucrose is hydrolyzed in presence of enzyme invertase. So this invertase enzymes, what they will convert into glucose plus 2 product, and again this glucose is react with the enzyme from yeast gymase. Gymase is the enzyme, 2 enzyme gymase. This glucose is fermented in absence of air, anaerobic condition will give again ethanol. So again what happens, if you mix here air, then it will convert into acetic acid and destroy the taste of alcoholic drinks. So here we have to do fermentation, not aerobic respiration. Now this ethanol is not good for our health. Ethanol is very bad for our health, so we should take as a medicine, not as a liquor, not as a drink. It's not a good drink. Why it is harmful? So ingestion of ethanol, it acts on central nervous systems. It directly attacks on the central nervous system, which is the important part of our brain. So in moderate amount, if you take moderate amount, it will affect the judgment and lowers inhibition. We cannot decide it. Whatever response we need, our brain is giving, that response is delayed. If you take the alcohol delayed the judgment process. We cannot give the proper judgment in time. If you take the higher concentration of alcohol, then you will cause nausea, loss of consciousness, we fall down. And if you take more higher concentration, it will interfere with the spontaneous respirations and can be fatal. Death can be occurs. So anyway, alcohol is not good for our health. We have to take as a medical purpose, not as a regular liquor like water. Boiling point of alcohol increases due to intermolecular hydrogen bonding. So if we have seen hydrogen bondings, if the hydrogen bonding of the alcohol increases, why? Because of presence of hydrogen bonding. So you can see here ROH. So here hydrogen bonded with the oxygen. So oxygen, hydrogen, this is a dotted line is called hydrogen bonding. Similarly, this is the alcohol. So between alcohol, hydrogen bonding take place, and due to which boiling point of the alcohol increases up. Again, alcohol also little soluble in the water. Why? Due to formation of hydrogen bond. You can see here this is water, this is alcohol. So this dotted bond, oxygen of this alcohol and hydrogen is again forming hydrogen bonding. Again, this O can second pair of lone pair of oxygen can form hydrogen bond with the another water molecule. And again, this hydrogen of the alcohol can form one hydrogen bonding with another water molecule. It means 3 water molecules surrounded by the alcohol. So in this way, alcohol is act as a so it is soluble in water with the help of hydrogen bonding. So now we'll see next part, how to detect double bond and triple bond. So double bond means carbon-carbon double bond, and triple bond means between carbon-carbon triple bond. So we have one process called Bayer's process. So under cold alkaline KMnO4 condition, what happened? Double bond, this carbon is react with the KMnO4. So color of the KNF4 red purple, so it will become colorless, so we will get the product alcohol. So this is discharge. Again, if you take triple bond, again you react with the red purple color of KMnO4, this is also discharge, means color of this also become colorless. This is the one test. So if the red purple color of the KMnO4 is colorless, this means the following compound is the double bond triple bond compounds. Now second process is using bromine water in CCl4 or chloroform. So here color the bromine water in double bond triple bond, it again become colorless. This is the second way to identify the saturated and unsaturated compounds. Now second is how to identify terminal alkyne and non-terminal alkyne. First of all, what do you mean terminal alkyne? So this is the alkyne, we have know that formula is very well. So here the hydrogen part attached with the first carbon is called terminal alkyne, and this is triple bond. But if this triple bond is present in between the two carbon, the first carbon and second carbon anywhere, second, third, fourth, anywhere, so this triple bond is called as non-terminal alkyne. So this is the difference between terminal and non-terminal alkyne. Now question is how to identify terminal alkyne and non-terminal alkyne. So for terminal alkyne there are two tests given by the alkyne groups. So one test is your Tollens test, and second is your Fehling solution. Tollens test means it is given by the terminal alkyne. So here Tollens test is actually ammonical silver nitrate solution. So terminal alkyne's hydrogen part is acidic, it is actually acidic. So this will react with the Tollens silver and give you silver mirror test. So if you get the silver mirror after the reaction of Tollens AgNO3 with the terminal alkyne, so this indicates the terminal alkyne is present in the substance in the given part. If non-terminal, do not give this test. Similarly, Fehling solution, actually Fehling solution is also given by the terminal alkyne. Fehling solution is two part. One is solution A, second is solution B. Solution A is called copper sulfate solution, aqueous solution, and solution B is called alkaline sodium potassium tartrate. This is a mixture of 1:1 molar mixture of these two solutions. So terminal part, this one, terminal alkyne react with the Cu2, Cl2 in aqueous conditions. So again what happens, this will anion. So the hydrogen will react with the copper, okay, and it will convert into water, and this copper is converted into, in presence of air, it will convert into oxide. So this is your ready, this color is Cu2 Cl2 will give you Cu2 red brown precipitate. So this red brown precipitate is the indication that the only terminal alkyne is reacting with this Fehling solutions. So these are two tests for identification of terminal alkyne from the non-terminal alkyne.